Good afternoon, everyone. I'm Koumudi Prasanna and I'm teaching the subject for mathematics for computing, and I'm working as an assistant professor in the Institute of Aeronautical Engineering in the Department of A&ML. Today we are going to see the topic of truth tables. So what is a truth table? Already we have seen that if we have one statement P and one statement Q we have. One statement P and one statement Q we have. Each statement will have two possible truth values. One is true and one is false. And based on the statements in the compound statements, based on the number of statements in the compound statement, that we can generate a table of these truth values, and finally we can draw the conclusion whether that statement is logically possible or not possible. How to do that? So we know that each statement have two constant truth values, so 2 power n. So this power n means number of statements. Number of statements in the compound statements, individual statements. Here in this statement I have one statement, two statements. So 2 power 2. So with 4 truth values, I need to construct a table. How to construct that? P, Q. So first statement T, both true values and both false values. And next alternative, true, false, true, false. So what is the possible combinations for this P and Q statements? P and Q statements is P and Q, P or Q, like that. So many statements we can generate compound statements. Based on this and the rules of this statement and notations, we can get the truth value. Suppose P and Q, both are true, only the true, remaining all other conditions it will draw the false value. P or Q, it will give the true value for everything, and false if both are false. Like that we can generate the truth table. So in this video we are going to see the examples of various problems, how we can generate truth values, and possibly based on these truth tables what kind of compound statement truth values can be there. So let us see the examples one by one. So first, negation of P or Q. Negation of P or Q. So already we have P, we have Q. Next, P or Q. So P is true, Q is true. Automatically P or Q is true. P is true, Q is false, then also true. P is false, Q is true, then also true. If both are false, P or Q automatically will give the false. And for this we need to do the negation of P or Q. So here true means it will become false, 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 true. Like that it will come. So like this we can take the truth values of the negation of P or Q. Let us see the next problem. Negation P or P or negation Q. First, this statement is P or negation Q, and negation of P or negation Q we need to calculate. So as usual, P, Q. Since we have a negation Q here, we need to maintain negation Q also. P or negation Q, negation of P or negation Q. As usual, P means 2 true values, 2 false values. First statement will follow like that. When it is not given in specific values, we can construct truth table for single statement like this. And Q, 1 true, 1 false, 1 true, 1 false. Suppose I have 3 statements like P, Q, R. So first one as it is half. So it is 2 power 3, that is equal to 8 values we need to generate. First 4 trues, second 4 false. Here 2 true, true false. 2 again true, remaining is false. Here alternative, true false, like that way. So based on the number of statements, we are going to generate the truth table and truth values and their sequence also. So here we are going to see is P or negation Q. P or negation Q. So this is P. P true means negation Q. Q true means negation Q is false. Q false means negation Q is true. Again it is true means it is false. It is false means it is true. Now we need to compare these two values. P or negation Q. P true, negation true, false. Yes, it is true. P true, negation on Q true, true. P false, negation false. If both are false, P or negation Q will give the false value. And in any one is true, it is true. For this entire statement, we need to do the negation. So it is true means false, true, false, false, true, true, false. Like this, we can know the truth value of negation of P or negation Q. So let us see the next problem. P and Q or P and Q. P and Q or P and Q. So two times the same statement repeated. So we are going to consider only one time. The same thing we will be using OR with the same statement. Same compound statement. So true, true, false, false. It is true, remaining three are it is also true. So both are true. It is true. Both are not true. So it is in remaining any situation it is false. Now we are doing the disjunction or between the same statement. So it is true means it is true again. So it is true. So same result will appear. So we can see what is the symbolic statement of this and are. We have two conjunctions and it will be represented like this, and we have one more symbol or it will be represented like this. So in mathematical expression also we can apply this logic and will give the multiplication result or will give the addition result. So whenever we are using one connective between the same statements, same that compound statement result only will come. Okay. So here again we discussed one more thing, and will give the multiplication logic or will give the addition logic. How we will see. Same two statements PQ. Let us have the binary values for it. 1, 1, 0, 0. 1 stands for true, 0 stands for false. 1, 0, 1, 0. Let us try P and Q. So it means multiplication. 1 into 1 in binary language it is 1. Anything is multiplied with 0 will give the 0 values. That we know. So P and Q and P multiplied Q will give the same logic here. And P or Q or plus. So 1 plus 1. Automatically 1 plus 1, 2 means 1, 0, that we will consider as 1. 1 plus 0, 1. 0 plus 1, 1. Both are 0, 0 plus 0, 0. That is the reason we can tell that and or conjunction will carry the multiplication format or disjunction will carry the addition format in the mathematical logic also. Based on this also we can construct the truth tables by using binary digits zeros and ones. Not only true as false, zeros and ones also we can use to construct our truth tables. Next, P or Q or negation P. P or Q or negation P. So we need P, we need Q, we need P or Q and we need negation P. All these things we need here. So P, to true, to false. It is true, false, true, false. P or Q. Remaining both are false. Remaining all the situations will give the true values. Okay. Fine with this. But we have negation P in the statement. So negation P we can take here. P true means negation P false. P true, negation P false. P false, negation P true. P false, negation P true. Now, in between these two statements, I am going to do the disjunction. When any one of the statement is true, automatically it is true. Again, one statement is true, true. Both the statements are true, true. And here, one statement is true, it is true. So, all the truth values have been given as a true for this particular problem. So, let us see the next solution for the next problem. So, it has given that negation of negation P and negation Q. One more time I am telling negation. This symbol is called as negation. So, it means that not. Suppose I am saying it is raining, one statement. What is the negation statement for it is? It is not raining. The negation statement for it is not raining. So, like that we can say. So whenever we are applying the negation, what is the original statement truth value will become as false. If it is true, it is false. If it is false, it is true. Suppose in stating a statement is that it is not heat here. The negation of that, it is very hot here. Like that we can do the negations. So here we have negation P or negation Q. So to find out negation P, we need P. To find out negation Q, we need Q. So it is negation P or negation Q means we need to have P. With that negation P, you need to have Q with that negation Q. With both of this negation P or negation Q, with the result of it only you can find out of negation P or negation Q. So P is having true truth values, 2 false values. Here 1 true, 1 false, 1 true, 1 false. Negation P. True values. So 2 false values, 2 true values. Here 1 false, 1 true, 1 false, 1 true. Negation P or so both are false here, it is false. In remaining any situation, it will give the true value. So it is a negation of this particular statement. Here we have a false. Automatically it will written as true. And remaining all the situations it is true. Automatically remaining all the situations we can turn it as a false. So you can find one thing is that P and Q is equivalent to negation of negation P or negation Q. They will give these both statements will give the same values or same truth table result. So we can find this equivalent here. Equivalent means what? These both can give the same result. These both can give the same result. So we can say these both statements are. Next problem is P and Q. So we are going to consider P one time and this P and Q is one time. P and Q and P are both are equivalent. Anyway, it will give the same result only because both the statements need to have true values. So P and Q. First P, Q we have written P and Q. First both true, remaining any condition it is false. So with this statement, we are going to using conjunction with P. True, remaining any condition it is false, so here also it is false. Like that we can say that P and Q will give same result as P and Q. That is the reason P and Q is equivalent to either Q and P. Is equivalent to Q and P. That we can see here. Next problem is P or negation of P and Q. P or negation of P and Q. So first we need to write P, then we need to write Q, then we need to write P and Q, then we need to write negation of this P and Q, then that we need to do the distinction with P. That we need to do the distinction with P. So P, 2 true values, 2 false values. Here 1 true, 1 false, 1 true, 1 false. So P and Q means only both are true, that condition is only true. Remaining every condition it is false. Negation with this, wherever you have true value, you will go it as the false and remaining every condition is true value here. Now, P or negation P, what is the condition for or? If both the statements are false or both the statements are zeros, then only the equivalence of disjunction is false. In any other condition, the equivalence of disjunction is true. So here P true, negation of P and Q false, so it is true. P true, it is also true, so it will also true. It is false, it is true. So it is also true basically. It is false, it is true. It is also true. Like this we can see that P or negation P and Q. So now we are going to discuss one more thing is that types of positions based on truth values. Types of prepositions based on truth values. So we can say preposition means what? A statement, a single statement or a compound statement. So based on truth values we can say whenever we have P, there is no doubt that one true value and false value will be there. When Q, one true value and false value will be there. But whenever we are writing this combination like P and Q or negation P and Q, Like that we are writing any combination here. If it based on this combination truth values, based on this combination preposition truth values, we can divide our into main three types. We can divide our prepositions. First one is tautology, second one is contradiction, third one is contingency. Tautology, when a preposition, now onwards a preposition means it is a compound statement, not a single statement like P or Q, negation P and Q, P or Q, like any compound statement. A preposition which is always true. A preposition which is always true is called as a tautology. In any condition it may come, it should come as true only. And contradiction. In any condition, your compound statement draw the value as false. Your compound statement draw the value as false. Automatically, that type of truth tables or prepositions compound statement will call it as a contradiction. Next, contingency. A preposition that is neither a tautology nor a contradiction. Like how we are drawing the normal values is P and Q. P or Q is both, they both are drawing true values as well as false values. That type of normal prepositions will be called as contingency prepositions. So we can see that in any situation if you are drawing only true value, that type of prepositions will call as tautology. In any situations only we are drawing the false values, that type of prepositions will call as false or contradiction statements or fallacy statements, and it is sometimes true, sometimes false based on situation. That type of prepositions is called as contingency statements. That we can understand based on this. So now we are going to we need to understand that any statement will have two truth values. Based on the number of statements, your truth table values will change. If you have only two statements, 2 power 2, 4 truth values will come. If your number of statements increases to 3, 8 to power 3 is 8. If your number of statements are increased to 4, 2 power 4, 16, like that. It is one. But here we can show any preposition or compound statement based on the values, what is the truth values it can draw. That we can understand based on this particular calculations, and this is the calculation for truth table values, how we can generate how. So first statement basically half truth values, half false values. Second statement, if you have only two, P and Q means 1 true, 1 false, 1 true, 1 false. 3 statements, second statement will carry 2 true, 2 false. So based on this number we can decide of the second statement. Last statement automatically it is alternative, 1 true, 1 false, 1 true, 1 false. Like that we can generate. That we can understand based on this. So based on this truth table only, these values or this type of declarations we can do. So this is the one method we can use to prove two particular prepositions are equivalent or not. So to prove that, one of the method is a truth table method. Like already I told you, here P and Q is equal to Q and P. Like that we can see this type of truth values or this type of comparisons we can do based on this truth tables to prove whether it is a contingency or whether it is a tautology or whether it is a contradiction is based on the final statement value. So this is the tautology, example of tautology. In any case it is showing only truth values means P or negation of P and Q is a tautology we can say. Like this we can. So this is the example, P or negation P. Always disjunction between the statements and its negation always will draw the truth value. Any statement it can be. So whenever you are using a disjunction with the statements and its negation, because if a statement is true, it will be false. If a statement is false, it is true. And you are using disjunction, automatically it will provide a tautology. Contradiction. If you are using the conjunction, with the particular, so P true means it will become negation P will become false. Automatically the result is false. It is false means it will become true, and you are using conjunction, the result is also false. Like this also we can. So always P or negation P is tautology, P and negation P is a contradiction. And contingency. It is the normal statement contingency. It can provide either true value or a false value. Now, no need to get any conclusion whether it is a tautology or whether it is a contradiction. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.